Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is the brilliant Victor. Today we're diving deep into the Java memory model, specifically the happens before relationship. This is a crucial concept for understanding how Java ensures visibility and ordering of operations in concurrent programming.
That's right, Sheila. The happens before relationship is one of those concepts that, once understood, can really elevate your concurrent programming skills. It's like the secret sauce of Java's memory model.
Before we dive in, let's start with a quick quiz for our listeners. Here's the question. In a multi-threaded application, thread A writes to a volatile variable, and then thread B reads from the same volatile variable. Can thread B be guaranteed to see all the writes that happened in thread A before the volatile write? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Sheila. It touches on some subtle aspects of the happens before relationship and volatile variables. I'm excited to see how our listeners tackle this.
Now, Victor, could you start by explaining what exactly the happens before relationship is?
Certainly. The happens before relationship is a fundamental concept in the Java memory model that defines when the effects of one operation are guaranteed to be visible to another operation. In simpler terms, if action A happens before action B, then the results of A are visible to B, and B cannot occur before A.
That sounds important, but it's a bit abstract. Could you give us an analogy to help visualize this concept?
Sure thing. Think of the happens before relationship like a relay race. In a relay race, one runner must complete their leg and pass the baton before the next runner can start. Similarly, in the happens before relationship, one action must complete and pass its results before the next action can use those results.
That's a helpful analogy, thanks. Now, I've heard that there are several rules that define the happens before relationship. Could you walk us through some of the most important ones?
Absolutely. Let's start with the program order rule. This rule states that each action in a thread happens before every action in that thread that comes later in the program order. It's like reading a book. You read page 1 before page 2, and so on.
That makes sense. What about when we're dealing with multiple threads?
Great question. That's where the monitor lock rule comes in. When a thread releases a lock, it happens before every subsequent acquisition of the same lock. This is crucial for understanding how synchronized blocks and methods work in Java.
I see. And I remember we talked about volatile variables in our last episode. How do they fit into the happens before relationship?
Excellent point. The volatile variable rule states that a write to a volatile field happens before every subsequent read of that same field. This is why volatile is so useful for ensuring visibility of changes across threads.
That's fascinating. Are there any other important rules we should know about?
Yes, two more key rules are the thread start rule and the thread termination rule. The thread start rule says that a call to thread.start happens before any actions in the started thread. The thread termination rule states that any action in a thread happens before any other thread detects that thread has terminated, either by successfully returning from thread, join, or by thread is alive, returning false.
Wow, that's a lot to take in. How do all these rules work together in practice?
That's where it gets really interesting, Sheila. These rules can be combined through transitivity. If A happens before B and B happens before C, then A happens before C. This allows us to reason about complex sequences of events across multiple threads.
I can see how this could be powerful but also potentially confusing. Are there any common pitfalls or misunderstandings developers should be aware of?
Absolutely. One common mistake is assuming that because Operation A finished before Operation B started in real time, A happens before B in the Java memory model sense. This isn't necessarily true unless one of the happens before rules establishes this relationship.
That's a great point. Could you give us an example of a bug that might occur if a developer overlooks the happens before relationship?
Sure. Imagine a scenario where one thread initializes an object and sets a flag indicating it's ready, while another thread checks the flag and uses the object. if proper synchronization isn't used to establish a happens-before relationship, the second thread might see the flag set to true but not see the fully initialized object, leading to subtle and hard-to-reproduce bugs.
That sounds like a nightmare to debug. What's the best practice to avoid such issues?
The key is to always use proper synchronization mechanisms like volatile variables, locks, or higher-level concurrency utilities from Java. util.concurrent. These establish clear happens-before relationships and ensure correct visibility across threads.
Thank you, Victor. That's been incredibly informative. Before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer is yes. Thread B is guaranteed to see all the writes that happened in thread A before the volatile write. This is because of the happens-before relationship established by the volatile variable rule combined with the program order rule. The volatile write in thread A happens before the volatile read in thread B, and all actions before the volatile write in thread A happen before the volatile write itself.
Excellent explanation, Victor. To summarize today's episode, we've learned that the happens-before relationship is crucial for understanding how Java ensures visibility and ordering of operations across threads. We covered key rules like program order, monitor lock, volatile variable, thread start, and thread termination. Remember, proper use of synchronization mechanisms is essential to establish happens-before relationships and avoid subtle concurrency bugs.
That's a great summary, Sheila. And to give our listeners a sneak peek, in our next episode, we'll be diving into memory barriers and reordering, which builds on what we've discussed today about the Java memory model.
Thanks for listening, everyone. If you enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth, educational content about Java internals. Until next time, happy coding.